All right, good afternoon. This is David Raymond from the Virginia Cyber Range, and this is our weekly WebEx, not a WebEx anymore, weekly Zoom meeting, our weekly cybersecurity workshop. This week we're going to talk about web application penetration testing. So we'll talk just a little bit about why websites are vulnerable. They used to not be, like in the early days of the web. Websites were pretty static, and so there wasn't much for malicious people to take advantage of. But now websites run code on the back end, and they run that code on behalf of the people who are visiting the website, and that can be dangerous, right? So there are all kinds of vulnerabilities that can sneak in when you start doing that kind of stuff. And today we're going to talk about one particular type of vulnerability, which is SQL injection. And if you don't know what SQL is, we'll get to that in a little bit. First, we'll start off with hands-on exercise. So we're going to get to a hands-on exercise in a few minutes. If you want to participate in this hands-on exercise in a environment that I provide, then you're welcome to go to the Virginia Cyber Range and use this invitation code to join the course. And if you already have an account and have a course, then we're going to use the Cyber Basics environment. So you can pause here if you need to and grab this invitation code. So here's my standard slide. Weekly workshops, once a week, coverage of various cybersecurity education topics. The intent is for educators to be able to use some of this material in their classroom, and either the news and or the lesson itself, it's all ripe for you to turn around and use it in the class. We do this live Tuesdays at 1 p.m. or I think the tradition recently has been most folks are viewing these after the fact. So we of course record them all and upload them on our website, and that way you can like play them back in double speed, and the whole thing only takes like 30 minutes. So if you'd like to see a particular topic, please email us. You can send an email directly to me, or you can send an email to contact@virginiacyberrange.org, and we will add your idea to the list of possible topics for future weekly workshops. Okay, we'll start with some recent news, as we often do. Here's a weekly news story. The first bullet there. This is from the news story is from SC Magazine, which is an online computing magazine, and they refer to the Malwarebytes annual report. So it's kind of funny. Their title of their news story says Malwarebytes 2018 report. Really what they're talking about is the 2019 State of Malware report, but it's reporting on their observations from 2018, right? And this is one of many annual reports that comes out from various cybersecurity companies, and there's lots of these. There's McAfee does one, Symantec, Sophos, CrowdStrike, a bunch of these companies do an annual report that talks about trends that they've seen over the last year in terms of malware and different kinds of attacks, and these reports are the difference in them is based on the kinds of technology that the company does, right? So Malwarebytes is a antivirus company, and so their annual report talks about mostly malware and things that they've observed, things that they're seeing, and sort of the things that antivirus would hopefully protect against. Like you would hope that your antivirus software would protect against things like ransomware, right? So ransomware is malicious software that ends up on your computer, and it encrypts large portions of the file system, and then asks for money to get your file systems back. So their report talks a lot about different kinds of malware, but they mention in the annual report, and that's what this news story gets to, is that the malware is getting more targeted. And so the quote here is from Marcin Klazinski, I guess is how you pronounce his name. So Malwarebytes is a Russian company, so it's so Marcin, I assume, is Russian or at least Eastern European. But what he says is that they're no longer using a shotgun approach, and that worries me. So he's talking about people who are attacking, doing different kinds of cyber attacks. It's more tailored, more targeted than it used to be, and frankly, we're seeing that right here at Virginia Tech. So we've seen a whole bunch of very targeted malware or phishing attacks, really. So we have people who are doing some research about organizations on the university, and they will, for example, identify a department head in an academic department, and then they will identify people who are in that department, and then they will send an email to the people in the department, and the email looks like it's from the department head, and there are ways to sort of spoof the from address, right? So it looks like it's a legitimate email from somebody at vt.edu when really it's not. And what they'll do is they'll ask that person, they'll make it seem like they're in a meeting. They can't call them, they can't talk on the phone, but they want them to like buy gift cards or something. And I think I showed one of these last week or the week before during the weekly workshop, one of these malicious phishing emails. So the point is that that takes some research on the part of the attacker. So instead of just blasting out thousands of these emails to a bunch of people who are not going to recognize the sender, and they're likely to just delete the email, if you can target it and make it look like it's from a specific person, then people are much more likely to take the action that you want them to take. And by doing a little bit of research beforehand, the attackers can be more targeted, and then they get a much better return on investment, much more higher click rate. So I also include the second bullet there. It's sort of related. This was something I saw on Slashdot here just this week. Google has released a pretty good phishing quiz, and this phishing quiz is based on real malware that that the Google security team has seen sent to Google employees over the past several months. And so I'm going to go ahead and click on this and just show it off really quick. So again, this is by Jigsaw, which is one of the Google companies. Google is really a whole bunch of different companies, and Jigsaw is one of them. And so can you spot when you're being phished? And if you click take the quiz, it says create a name and an email. Neither need to be real to make this quiz seem more realistic. Don't worry, this information won't leave your device. Okay, so I'll put in here test, and I'll say test@gmail.com, and I'll spell it right. Okay, so here's the first email that you have to decide if it's legitimate or not. Let's start with this Google Doc email. So what you have to do is analyze the email and then click on either whether it's a phishing email or a legitimate email. So here we have an email from luke.json. So name is Luke Johnson, luke.json8000@gmail.com. Me, so it's to test@gmail.com. Okay, so far, the only thing that would make me suspicious so far is that I don't know who Luke Johnson is, and he's sending me stuff, so that makes me a little bit hinky about this whole thing. He wants me to pull down this document, Word document. But if I hover over the document, it says Luke Johnson has shared a link to the following document. So this is supposedly a Google Doc that's been shared with me. And if I look at when I hover over the link, I see the URL coming up in the lower left-hand corner. If you look at that, it looks like it is from drive-google.com/luke.johnson. And the thing you're supposed to be able to pluck out as being incorrect is the fact that it's not drive.google.com. It's got these dashes in it. If I can find my pen, I'll circle it. Maybe that's not going to work on a website. But if you look at the URL, it's drive-google.com, and that is that you're supposed to be able to recognize that that's invalid. And so if you click on phishing, then it says, you must have spotted the lookalike URL. Be cautious about hyperlinks and attachments you open from emails. They may direct you to a fraudulent website, right? So apparently drive-google.com is fraudulent, and that was supposed to tip you off. Frankly, what I would, with this particular email, I would never click on this, because even if the URL seemed correct, if it was drive.google.com/whoever, if it's somebody I don't know, then I'm gonna not click on this, because if it's from some random person, then it could be malicious. Mouse over. Okay, so to give you a little bit of help here, mousing over this link or using a long press will show you that it goes to the insecure imitation domain drive-google.com. If you go to the next one, you received a fax. We know you're excited, but take your time. So here's a fax message, no reply. So it's no reply at efax.com, and it's to me, test@gmail.com. And if I hover over this one looks really suspicious. If you look at the URL down on the bottom, it's http efax.hosting.com.mailru382.co /efax delivery / big long number. This is pretty clearly malicious, right? Or it's certainly deceptive, and that should be sufficient to tell somebody not to click on this link. It's a phishing email. So that's you get the idea, right? It's several emails. Some of them are phishing emails, some of them are not, and this is I've seen some phishing quizzes over the years, and this is probably one of the best, just because it's based on some real phishing attempts that the Google folks have seen. So it's not a bunch of made up things. And that is at it's at https phishingquiz.withgoogle.com, and even that link looks a little suspicious, right? Withgoogle.com. I've not heard of that before, but trust me, this is legit. Okay, here's another news story. The next bullet: too few cybersecurity professionals is a gigantic problem for 2019. This is a TechCrunch article, and this is one that just highlights the cybersecurity shortage. The shortage of people in cybersecurity positions, and every time I see that, it makes me remember why we're doing what we're doing. And it does mention some efforts around the country to improve the state of cybersecurity expertise. Doesn't mention the Virginia Cyber Range, but I'm sure that's just an oversight. Okay, so next slide, crypto news. New ransomware strain is locking up. So these two news stories are related. Of course, they're both about cryptocurrency, but they're related beyond that. And we'll see if we can pluck out why I think they're related. New ransomware strain is locking up Bitcoin mining rings in China. So this is software, malicious software, ransomware that is targeting some very specific computer systems that are designed to mine Bitcoin, right? So, in the early days of Bitcoin, people mined Bitcoin with just off-the-shelf systems, servers or desktop computers, but Bitcoin mining requires pretty specific kinds of operations, and you can imagine that if you architect your systems well, you can sort of minimize the cost while maximizing the compute power that's devoted towards the very specific functions that are required for Bitcoin mining. So there are a handful of systems that are designed specifically to mine cryptocurrency, and there's not very many vendors who sell that kind of hardware. In fact, it's hard to get. There's a waiting list for most of that stuff because they're pretty people buy like thousands of them at a time to outfit large warehouses to mine Bitcoin or other cryptocurrency. But it's a relatively small number of vendors, and there's this ransomware that is targeted at a very specific subset of those systems that you can purchase to mine Bitcoin. So that I thought was kind of an interesting story. Ransomware that's targeted towards a specific computer system instead of just trying to lock up anybody who they can get to pay. This ransomware is targeted at specific Bitcoin mining systems. And then the next news story there: security flaws found in 26 low-end cryptocurrencies. So this is this story is about malware that is used to crash systems mining some very specific cryptocurrencies, right? So these security flaws are found in not particular hardware, but particular cryptocurrency software. And so the way that both of these stories are related is probably pretty obvious, right? Both of these pieces of malware are designed to lock up systems that would otherwise be mining cryptocurrency, either Bitcoin or some other crypto software. And if you recall, I think 2 weeks ago we talked about a 51% attack on cryptocurrency, right? So if you can amass more than half of the compute power that's devoted to mining any specific cryptocurrency, then you can change the blockchain to suit your needs. And so one way you can get more than 51% of the compute power is you can buy more hardware than everybody else put together has, and then use that to mine more coins than the other guys put together. But that's pretty expensive. What might be a better kind of an attack is you write malware that targets systems that are mining the kind of cryptocurrency that you are mining, and then you lock up as much of the competition as you can, and then it's a lot easier to get more than half of the compute power that way if you just make other miners not mine anymore. And if you can do that, if you can sort of blitz that out and get a whole bunch of them offline even for a short duration, then you can dump your bogus chain, your bogus blockchain, and essentially revert a bunch of money that you spent, so it looks like you didn't spend it, and then you can spend it again later. So I don't know, a couple of what I thought were sort of interesting stories related to cryptocurrency. Okay, so today we're going to talk about web application penetration testing, and next week we're going to we'll hit SQL injection first, and then next time we'll talk about command injection. So here's the slide again, and my slide is wrong. So invitation code here. This invitation code expires on January the 29th. So if you're listening to this after the 29th of January and you want to get an updated invitation code so that you can get access to a Cyber Basics environment, then just send an email to support@virginiacyberrange.org and we'll take care of you. The alternative is just if you already have a CyberRange account and you have a Cyber Basics environment that you're using with your students, then you can just use your own Cyber Basics environment. And the hands-on exercise we're going to do today is the SQL injection lab. So if you log into the courseware repository and in the search bar type in SQL, then it'll come up as an exercise and you can download it. Okay, so with that, I'm going to pull up another slideshow. All right, so today we're going to talk about web application vulnerabilities, and you know, it helps to have some understanding of how the web works, and then I'll talk a little bit about that. But you know, it would help to have a little bit of understanding of sort of how the back end of the web works, and in this particular case, it would also be helpful to understand a little bit about SQL, or structured query language, SQL. So SQL is a language used to interact with databases. I'll give a little taste of it, but you know, if you want to sort of fill the gaps with your students before you use this particular hands-on exercise, you might do one lesson on structured query language and what that's used for and how you use it, and that would just put all this in a little bit better context. So learning objectives, we're going to talk a little bit about how web servers have evolved and why that's led to some various web application vulnerabilities. We're going to understand the classes of vulnerabilities in web applications that could lead to compromise. And again, again, today we're going to focus on SQL injection, which is just one of a handful of different web application vulnerabilities. And then we're going to actually do hands-on SQL injection attack against a website in the Cyber Basics environment. Okay, so we'll sort of frame the problem a little bit. So for you history buffs, the World Wide Web was born in the early 1990s. Right around 1991 is when the first software was written, and it was created by a guy in Europe. His name is Tim Berners-Lee. I think he's Dutch, and he still works in a company or in a government organization, European Nuclear Research Organization. The acronym is CERN, capital CERN, but it's a nuclear research organization in Europe. I'm sure it has a European name, different than what I just said, but Tim was a system administrator at CERN, and he wanted to have an easy way for researchers to be able to share information in an automated way. And email is one way, but he wanted it to be a little bit more permanent, so that people could, put stuff in a location where other people could come visit, and they could click on links, and they could see, download each other's papers and that kind of stuff. And so he came up with this web server software, and then he also wrote a web client. So he wrote the first web browser, Mosaic. Some people may have used that many years ago, back in the early 1990s. Mosaic was the first browser with a user interface, right? So the very earliest browser that Tim Berners-Lee created was a command line thing, but it was followed very quickly by the Mosaic browser that looked a little bit more like what you see today. And it was the way it all worked was very simple, right? So the web server software ran on a server, and on the server there was a file system, and the file system was just a bunch of files, right? And so Tim Berners-Lee created this HTML language, and it's just a markup language, right? So this notion of markup languages was not a new thing. He didn't invent markup languages. There are several of those in existence, but the markup language that Tim Berners-Lee created was specifically designed, first of all, to render pages in a GUI browser, so that they looked, so that they were sort of readable and had a headline and paragraphs and that kind of stuff. And it also was set up so that that web pages could link to other web pages. Basically, files could link to other files. And so an HTML file in those long ago early days was just a file that was stored on the web server. And here's an example. So you have an HTML tag that says, here's the very start of the HTML file. And then you have the header portion that gives the title to the web page, and then you have the body, and in there you have the headline, and you have, paragraphs, and you have links to other stuff. And at the very end, you have this close HTML tag, and that's the end of the file. So folks who were writing web pages back in the late 1990s or even into the 2000s, people would actually sit down with a text editor and they would write HTML. And that would be a file, and you'd save the file to a location on the web server, and then when somebody browsed to that file, then that page was rendered on the browser, and it was, it was all very, very straightforward. So this browser software, when you go to a website, it creates this HTTP GET request. So this is HTTP Hypertext Transfer Protocol. We've talked about that before in our networking discussions. It does this GET message, and it sends that GET message to the web browser, and or to the web server, and then the web server simply looks in its file system and says, is that particular file here? And if it is, it returns the file. and then the file is sent back to the web browser. And so here in this example, I went to this WC3 website. I think this is wc3.org, which is the World Wide Web Consortium. And it's very simple, right? It's, again, this is just an HTML file, and if if you're good at HTML, then you can make all the columns line up and make it all look good like this one does. So pretty straightforward. All the web browser does is it asks the web server for a file, and the web server returns the file. Okay, now it's gotten a lot more complicated, and this didn't happen overnight, right? This sort of was an evolution over time. It didn't take very long, so it started to get complicated in like even the mid to late 1990s. But now what you have with web servers is you have a browser submitting a GET request to a web server, and the web server might return some file. So if you think of somebody browsing to google.com, you send your GET request, and the web server is going to return, in this case, a form. And the form in this case is the Google homepage, and it's got a field in it where you can type stuff. The user can type stuff, and then that stuff that the user typed is packaged up by the web browser, and it gets sent to the web server, and whatever the user typed is going to get sent, in this case, to a database, and the database is the Google, the list of web pages, and the database is going to return some answer to the web server, and then there's going to be some web template that the web server is going to grab out of its file system. It's going to put all that together, and it's going to send the results of that database access back to the user. Okay, so now it's not just a web server asking, or I'm sorry, a web browser asking a web server for a file, and the web server returning the file to the web server, to the web browser. It's not that simple anymore, right? Now you have the user who can interact with a web page, and that, whatever the user types in, is going to get sent to the web server, and then the web server is going to do something on behalf of the user, and the web server is going to use the stuff that the user typed into that field to take some action. And that opens up this whole host of different opportunities for people using web browsers to abuse what's going on the web server. And in this case, we're going to abuse the database. So the database interaction between the web server and the database, this uses this language called structured query language. And so we'll take a look at that next. Here's a whole list of different web-related vulnerabilities. One of them is SQL injection. We'll talk about command injection next time, but there are lots of others, right? So, so here's an example web page that's asking for a username and a password, and that username and password is stored in a database in almost every case, right? So this SQL injection attack that I'm talking about, you could potentially use that on just the very simple web page that's asking you for a username and a password for whatever website you're going to. Another way you can abuse this kind of a web page is you can do this thing called account harvesting. So some websites, if you type in a username and then a password, and if the username is valid but the password is not, then you might get an answer back that says, this password is invalid, please retype your password. However, if you instead type in a username that's invalid, and then a password, doesn't matter what the password is if the username is invalid, you might get a response back that says, this user doesn't exist in our system. So in that case, you're getting a different error message based on whether you put in an incorrect username or not. And if the web server gives you that kind of an answer, then what you can do is you can put in a whole bunch of different usernames, and you can identify specific users who are valid in that system. And why is that useful to an attacker? Well, that's useful because now you can do password guessing attacks with a list of known users, right? So you're sort of wasting your time if you do a password guessing attack with a bunch of random usernames that you don't know if they're even valid or not. But if you first work through a list of known users and then do password guessing attacks using those known usernames, that's going to be a lot more efficient for the attacker. So that's what this notion of account harvesting is. And then brute force password guessing, that's when you have a known username and you have a software system that will enter that known username again and again, but it changes the password on every attempt. And you could pull those passwords from a password dictionary, right? So we've talked about password cracking, and we've looked at some password dictionaries that you might use for this. And there's some specific software that'll do these password guessing attacks on websites. Session stealing and cross-site scripting, those rely on the ability to eavesdrop on a web connection, and then in some cases, if you can eavesdrop on an existing connection between somebody using their web browser who's logged into a particular website. If you can eavesdrop on that, then you could potentially do this thing called a session stealing attack, where you basically take over that session and look to the web browser or look to the web server like you're the valid user, and really you're not. So this list is not all inclusive. And we may touch on some other, this is kind of the low-hanging fruit for web-related vulnerabilities, but a lot of the web vulnerabilities are based on poorly written code, and those can be, things that aren't on this list. Okay, so again, we're going to start with SQL injection. So I'll talk about SQL injection a little bit, and then we're going to do it. We'll do it in the cyber range. So SQL injection are attacks against web applications that have backend databases, and almost every website these days relies on a backend database. So if you think of what you use the web for, if you go to Amazon to buy things, the back end of that is all this huge database of products that are available on Amazon, and the database contains the name of the product, the price, the vendor, et cetera, et cetera, et cetera. If you use the web to read the news, those news articles, those aren't, you don't have some little old lady who's typing out news articles like crazy every time you request one. Those news articles are all stored in a database, and they come from places like the Associated Press or UPI. I don't know, is UPI still a thing? Anyway, those news articles are not independent web pages. They are stored in a database. Even the ads that you get served when you go browse to a website and you get a bunch of ads on the side or in the bottom or on the top or whatever, those ads are all coming from a database somewhere, a database of ads that are being offered up by Google or Facebook or whoever. So there's lots of potential for SQL injection attacks, and just about any time you have a website where you have a thing that you can type something into, like here in this example, there's a search bar, right? If you're going to do a search on a website, it's going to use a database as the back end of that thing. Or if it's asking you for a username and password, or an email address and a password, again, that data is stored in a database. So just about any time there's a form field that you can fill out and click, there's going to be a database lookup on the back end. And again, this is a situation in which you're going to have the web server take some action on your behalf based on data that you typed into something on a web page. And an SQL injection attack generally takes advantage of improperly validated user input. And we'll take a look at what that means as we do it in a hands-on way. And then so you got to look for pages that allows the user to submit data, again, like a login page, search page, item lookup, feedback form, etc. Okay, so here's a quick overview of structured query language. Again, it would be useful to have a little bit broader discussion of SQL with your students. That's something you could easily do in an hour-long class session. But structured query language is a language specifically used to interact with databases. And a database is organized into tables, and the tables contain fields and records, right? So so if you look at this table, it looks a lot like a spreadsheet data. It looks a lot like a spreadsheet, right? So you can imagine a spreadsheet where you have a list of field names across the top. Here I have user ID, user, first name, last name, password, and then each row in the table is a record. So record number 1 is the user's admin, the first name is admin, the last name is admin, and then there's this password. And then the user ID 2 is Gordon B, Gordon Brown, and then here's a password. Hey, this is, I don't know, in this case, it might really be a password. I don't know if maybe it's supposed to be a hashed password. But that's so in a relational database, you'll generally have many tables, and this particular table in this case is the users table, and it's in a particular database that we're going to look at here in a second, and it's in this DVWA application that we're going to look at. So SQL is used to manipulate data in relational databases. And so here are some of the things that you can do using SQL. Probably the most widely used SQL statement is the select statement. And you do things like you say select some column from some table where, and then you have some search criteria, right? So here's an example. We have the select statement. In this case, we're going to say select user from users. So this is the name of the table. So select the user field from the users table where the user ID equals 1. So if we go back to our example table, if we say select the user field from the users table where the user ID equals 1, then what you're going to get returned from that select statement is admin. So here in this example, you're going to get admin. Okay, if you were to say select user from users where user ID equals 4, select user from users where user ID equals 4, and in that case, you're going to get Pablo Picasso. So if this was 4, then the answer would be Pablo. So hopefully you get the idea from that very simple example. So select, that's used to look up data in a database. That's probably, again, the most widely used SQL command. Another command that's used quite a bit is this command update. So you can say update, and then you can put the name of the table, and then you say set column equals value where search criteria. So here you might say update users, so update the users table, set last name equals Smith where user ID equals 1. Okay, so update the users table, set last name equal to Smith where user ID equals 1. So let's go back and look at our example. Okay, erase some of the stuff on here. Okay, so if I say update the users table, and I'm going to update, I'm going to set last name equals Smith where the user ID equals 1. So what the database would do is it would find where the user ID equals 1, and then it would go to the last name field, and it would set that value, in this case, to Smith. Okay, so that's how you change data in your database. And then there's lots of other useful commands in SQL. There are commands like drop, there are commands like delete, commands like shutdown, and those do things like they drop data, drop tables out of the database, they can delete rows out of the tables, or they can shut down the entire database, which, if you're Amazon and somebody runs a shutdown command against your database, then you're going to be in trouble. So be careful with those, right? Even in your DVWA test example set, if you do one of those, then you could break your database. You have to reboot things in order to get it to work again. Okay, so now we're going to, before I go on to the next slide, I want to log in to the Cyber Range. And we're going to do some of this. Console.virginiacyberrange.net. Sign in. Sign in as student. I'm going to go to my weekly workshops course, and I'm going to go to my Cyber Basics environment, and I'm going to click Start. Okay, so my Cyber Basics environment is starting up. While it's starting up, I'm going to take a look at this hands-on exercise. So this laboratory exercise is the Web Application Security SQL Injection Lab. Again, if you go to the courseware repository and you type in SQL, then this lab document will show up on the list of possible downloads. And here, resource required. We're gonna use the Cyber Basics environment, and it's in Cyber Basics. We're gonna go to this DVWA. Oops, clicking on stuff. My thing's going crazy here. Initial setup. Log into Cyber Basics using student as the user credentials, and then I'm gonna log into DVWA. So now my Cyber Basics environment is all fired up and ready to go. Log in. I'm just following the instructions from the lab, so I'm going to click on my web browser, and I'm going to go to http dvwa.example.com. And so I get to this DVWA database, and this is running on another virtual machine in the Cyber Basics environment. So so the system that you're on is your Kali Linux virtual machine, and the DVWA is a website that has a database backend that's running on another virtual machine in the Cyber Basics environment. Okay, so I've brought up the DVWA web page, and now I'm going to log in using the username admin, and the password. Okay. Now I've logged into DVWA. Now, you have to do this in the Virginia Cyber Range. If you go to dvwa.example.com in your web browser that's not in the Cyber Basics environment, then this is not going to work at all, right? So this is again, this is a website that's running in your Cyber Basics environment. And DVWA says, welcome to Damn Vulnerable Web Application, and gives you a lot of explanation about it. We're going to look at one component of DVWA today, but there's lots of other stuff going on in here. You could use DVWA for weeks in the classroom to teach different kinds of web vulnerabilities to your students. First thing we're going to do, again, I'm following the instructions here in the lab. Once logged in, click on the DVWA security button on the left side of the page and set to low, then click submit. Okay, so there's this button that says DVWA security. I'm going to click on that. And here's one of the cool things about DVWA. It has multiple security levels. So it is, by default, it's set on the impossible security setting. And basically, impossible is extremely difficult, if not impossible, to hack. The low vulnerability setting makes it very easy. The medium vulnerability setting makes it a little bit harder. The high, I guess, security, low security, medium security. The high security option is even more difficult. And then the impossible category says this level should be secure against all vulnerabilities. So what you can do is, as your students figure out we're gonna do a very basic SQL injection attack. Most websites these days are secure against the kind of thing that we're going to do today, but there are other approaches to SQL injection, and if your students were to get better at it, they could ratchet up the security level and test their skills. So I'm going to set this to low, and then I'm going to click submit. And then you'll see in the very lower left-hand corner, username is admin, security level is low. So now I'm going to click on SQL injection. And security level is low. So so it has a blank user ID field. Basically, it's what this is asking for is, okay, so the lab has this SQL primer that I just talked through. So same examples as before. So now I'm clicking on the SQL injection page, and so now the input box on the SQL injection page asks for a user ID. If you enter a 1 in this field, the web page constructs the following SQL query. Select first name, comma, last name from users where user ID equals 1, right? And the table that it's pulling that data from is this table that we just looked at in the slides. It's a table of, it's the user table from the DVWA web application. So it's got a list of user IDs, 1, 2, 3, 4, 5, 6, and then it's got users, so those are the usernames, and then it's got first name, last name, and password. And so the particular query that this page is going to use when if I were to put in a 1 or a 2 or whatever, it's going to do a select, whatever, first name, last name from users where user ID equals 2. So I'm going to I'll put in a 1 here to start with. First name admin, last name is admin, right? User ID equals 1, first name is admin. So it's doing that lookup. If I put in a 2, I'm going to get the expected result here. So if I put in a 2, I get first name of Gordon, last name of Brown. If I put in a 3, I get, I get first name Pablo. Oh, in this case, it's my table is different, but in this case, it's first name is Hack, surname is me. So how can I abuse that, right? So think about, when I put in that 1, here's the query that's going to get constructed. Select first name, comma, last name from users where user ID equals 1. And the red is the thing that I typed in, right? So the red is the user input. Now think of the following. If I were to enter this string instead in that user ID box, if I were to put a 1 and then a close quote and then an or statement and then user ID equals 2 and then call these hashtags these days that we used to call them, what did we used to call them? Number sign. Anyway, if I were to put that in, then the query that's going to get constructed is going to be a little bit different, right? And again, the red stuff is the stuff that the user typed into that user ID field. But if the database was to see this select statement, select first name, comma, last name from users where user ID equals 1 or user ID equals 2, then it's going to have, then the behavior is going to be different. So maybe we just try that. So remember, if I put in a 1, I get the thing that you would expect. But if I put in a 1, close quote, space, or user ID equals 2, and then, okay, now I got different behavior. So here I got first name equals admin, surname equals admin, and then but I got another answer. I got first name equals Gordon, surname equals Brown. So in this case, it gave me the information from rows 1 and 2, and that's certainly not intended from this. That's not what the designer of this particular web page intended to happen. The intent is for somebody to type in a single user ID and get out a single result. But you can also do more interesting things, like I could say, or 1 equals 1. So if I were to say user ID equals 1 or 1 equals 1, now I get everything out of the database, right? So it turns out that this database, 1, 2, 3, 4, 5. Only has 5 rows in it. But when I put in the 1 and then I close the single quote, and then I say or 1 equals 1. So what the closed single quote does is this whole section. Let's see if my pen works on a Word document. Oh yeah, it does. So this whole section on my SQL command after the where, this is all the search criteria, right? So so here I say select first name and last name from the users table where, and then the rest of this is the search criteria. And if I say where user ID equals 1, and then I close the quote, and then I say or user ID equals 2, then it's going to give me the search criteria now is these multiple things, right? It's this or this. So if I were to say user ID equals 1 or 1 equals 1, then 1 equals 1 is always true, right? So what's going to happen is this is going to be true for every line in the database. And so when I type that in, I get back every line in the database. And then this number sign, hashtag, whatever you call it, this thing at the end, what that is in SQL is that's a comment line. And so that tells the SQL, that tells the SQL interpreter to ignore everything after that. So this tick that's still left, the close quote that was supposed to be filled in after the first one, that thing is now ignored. And so this gives us a valid SQL statement, which is partially malicious, right? Because this is extra stuff that I'm jamming in there. So that's sort of the basic idea behind SQL injection is you can type different things into that field and you can get different information out of the database. And if I go back to my slides here, I think I have some more examples of malicious things that you can do. So here's that. So here's what we did in that example, right? If we put in a 2, then it's going to we're going to match. We're going to get first name and last name from the users table where user ID equals 2. So that's this column or that's this row, and so we get out Gordon and Brown. What does the query look like when you enter tick or 1 equals 1? That's what we just did, right? We added a bunch of extra information in there. 1 equals 1 is always true. So as the system looks through the fields to see which ones match, it's going to match all of them, and so you're going to get all of the first name and last name out of the user table. I'm not going to delve too much deeper into it, but these slides are slides that you could use in class even without the hands-on exercise. So if you didn't want to hand out the hands-on exercise, if you want to go through the slides in class first and let the students do it along with you, and then hand out the exercise at the end, that's another way to approach this. These just walk through it, but it gives other things to try, right? So there's a slide in here that says, try to figure out the tables. So you can actually, so what we got was information on each one of the users in that one table, but if you hack a little bit more, then you can get information about the tables themselves. You can disclose the name of the database. You can disclose all of the table names. So it's pretty powerful. I mean, you could pull out all those password hashes and then run those hashes through your password cracking system. Lots of malicious things you can do, and it's all based on that very simple SQL injection example. Last thing I'm going to show really quick is we saw that you could set the difficulties to some different levels, and I'm going to try to zoom in a little bit here on my web page. I may not be able to do that. Or zoom out, zoom out. Okay. But if you look at the very bottom right corner here of the page, so this is my SQL injection page. If you look at the very bottom right corner, you can view the source code. So this is the source code for the PHP code that runs the back end on this website. And so so here's the ID that the user types in, and that comes from the field on the web page. So the user types in an ID, and then here's the SQL query: select first name, last name from users where user ID equals $ID. That's the thing that the user put in, and then the data comes back from the database, and then the web page displays it on the screen, right? So and this is the low security version of that PHP code. And what you can do is you can click the select all levels button. And so this shows the low security PHP code on the very bottom. And then if you go up to the next level, it shows how you can write the code to make it a little bit more robust. And so in this example, it adds a line to do this SQLi real escape string. And so what that does is it tries to make sure that there's not extra characters in the user input. If you go up to the next line of code, it it spits out some kind of an error message if there's any extra stuff in there. And then whoops, and then the top line of code is this is the supposedly impossible version. What does it do? It gets the ID. It makes sure that the ID is between specific specific endpoints before it even spits it out to the back end database. So anyway, it's just more and more secure PHP code, but it's helpful to be able to compare the different pieces of code to each other. So if the students are, for example, learning PHP in a class, then this is a tool that you could use to teach them how to write secure PHP. Okay, and I'm going to end there. Next time, we're going to talk a little bit more about web application vulnerabilities and delve into some command injection vulnerabilities. And so thanks for tuning in, and we'll see you next week.